Previously on the Mirror Killer. Last time, we met the molecule with no face. We met Kate Adamala, a synthetic biologist who wanted to build a cell that could sneak past the immune system to fight cancer. And we left off at the moment the real investigation began. She asked the question. Now she has to live with the answer. Act 1. The horror in the hypothesis. Picture this. A mirror bacterium escapes the lab, maybe an accident. A gloved hand that wasn't quite gloved enough. A ventilation failure. A fire drill at the wrong moment. The mirror bacteria enter the wild. And here's the nightmare. Nothing on Earth knows how to fight them. Your immune system evolved over 4 billion years to recognize one thing: the chirality of natural life. Every virus, every bacterium, every fungal spore, your body reads them like a fingerprint. But a mirror organism? It has no fingerprint. It doesn't fit the lock. Your immune cells stare at it like a blank wall, and it just grows. Dr. David Relman of Stanford University warns, there is the possibility that, with admittedly a great deal of work, we could create something which could grow inexorably, spread across the planet, and displace or kill many, many forms of life, including us, the animals around us, the plants around us, and even some of the microbes. Not a pandemic, not a war, an extinction event. And it starts in a laboratory that thought it was saving lives. Act 2. The case breaks open. It started as a hunch, a worry at the edge of a cocktail party conversation. But the more Adamala talked to the right people, immunologists who understood the body's defenses, the clearer the picture got. The mirror organism wouldn't just evade your immune system. It could also resist every antibiotic ever developed. Flip the molecule. You flip right past the treatment. There are also the things no one can predict. Evolution. A mirror bacterium that escapes containment doesn't just survive. It adapts. It evolves. And evolution, once it starts, cannot be called back. We still can't predict how normal bacteria evolve in the wild. A mirror bacterium? We would be flying completely blind. The immune systems of every animal on Earth, developed over billions of years of coevolution, would mean absolutely nothing. Act 3. The confession. Kate Adamala could have stayed quiet. She had a funded grant, a promising career. She chose differently. In December 2024, she co-authored a landmark article in the journal Science, signed by 38 scientists, among them Nobel laureates. The message was unambiguous. Stop. Do not build a mirror organism until we have compelling proof it is safe. And right now, we have no such proof. Adamala says, experts in biosafety and immunology thought it was science fiction, and then they sat down and thought about it harder. The scientist who once dreamed of a cell invisible to cancer now works to make sure it is never completed. Not because it failed, because it might succeed too well. Act 4. The fine line. Here's the nuance, because good science always has nuance. Small mirror molecules, still valuable, still safe. Small mirror molecules are already in clinical trials for cancer, HIV, and COVID-19. The line is drawn at self-replication. Once you build a mirror organism that can copy itself, you've crossed into territory where no one has a map. And there is no coming back. The proposal. Set a size limit on mirror DNA. Ban the stockpiling of mirror components. Governance for a frontier that doesn't exist yet, because it's much easier to draw a line before someone crosses it. This is about wisdom over speed. The verdict. Every great detective story ends with a decision. Kate Adamala made hers. She walked away from an audacious experiment. She and 37 colleagues stood up and said, not this one. Not yet. Maybe not ever. That kind of pause is its own kind of courage. The mirror and the abyss. Sometimes the most important discovery is knowing which one you're looking into, and having the wisdom to step back. Learn more about the scientists and the stories behind the science at unbedsidemanners.com. Part 2 concludes here.